Hello and welcome, my dear grade 9 elite students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session. In today's session, we are going to be revising, especially for grade 9 elite, for your coming Math Term 3 exam from the exam coverage Part 2 Learning Objective 19. So let's get started and see what we are learning today. In today's video on Learning Objective 19, we are going to write and solve absolute value equations and graph the solutions on the number line. So in today's video, we are solving questions 1 to 8 given in your math book on page 517. So as you see, for each question, we have to first solve the absolute value equation, and then we have to check the solution and graph them on the number line. So let's solve all of these questions one by one. And as you would see when we solve these questions, there are going to be three types of solutions for these kind of equations. Let's discuss these three solutions in the next slide. The three types of solution that an absolute value equation is going to have are the following. Let's draw a flowchart just to keep things easy and clear for you. So there are three divisions. The first kind of solution you can have is two solutions. Two solutions means you will get two values of the variable. Usually the variable you are taking is x, so you will get two values of x. So there will be two different solutions. The second type of solution is one solution. This happens when you have extraneous roots. That means you may get two solutions, but when you put it back in the equation and check your solution, only one of them will come to be true. So this is one solution. And the last is no solution. That means there is no solution to the given absolute value equation. In that case, we can give the solution set to be the empty set, also called as the null set. So you will give your solution set as this. This is called phi, and it is a Greek symbol to denote an empty or null set, which means there is going to be no solution to the given absolute value equation. Let's now solve the first equation and see what category of solution we get. The method to solve every absolute value equation is going to be same, so please follow carefully what steps I'm doing. So first we do step 1 to solve this equation, which is we look at the absolute value equation and see how we can divide it into two cases. Remember, an absolute value equation has an absolute value function which is denoted by these bars. So if you see these brackets here, it means that this is an absolute value equation having absolute value function. Also, I want you to remind that absolute value function always gives you positive result. Okay, it can never be negative. Just remember these few points, and now we are ready to solve the question. So in step 1, we take two cases. Case 1, I will divide the screen so that I can show you both the cases, and case 2. So in case 1, the right side of the absolute value equation, which is 2p minus 3, this one will be positive. So I open these brackets and 8 plus p comes on both sides in both the cases, and the difference between the two cases will be, in case 1 the right side will be positive, and in case 2 the right side will have a negative sign. So this is a basic difference when you do the two cases in step 1. Now the variable here is p, as you can all see, so we have to solve for p, so we collect the like terms together. So I'm going to move this p on the right side so that I can combine it with the like term 2p, and minus 3 I will combine with the number 8 here, and it will change side, so it becomes plus 3. P goes to the right from the left, so it becomes minus p. So we get the value of p from here as 11. So this is one solution or one value of p. Now let's solve this also. Because there's a negative sign, when you open the bracket, the terms change sign, and again you solve by collecting the like terms. So I move minus 2p here and 8 here, so it becomes p plus 2p equal to 3 minus 8, which gives you 3p equal to minus 5, or p equal to minus 5 by 3. So till now we have got two values of p, but we are not sure that they are solution until we do step 2, that is where we check the solution. So as the question had mentioned when you read it in the beginning, you always have to check your solution for an absolute value equation. The method that we are going to use for checking is called substitution. So we will take the value of the variable that we got and put it back in the original equation. So let's first check p equal to 11. When I do that, I replace wherever there is p with the value 11 in this equation. So the left hand side becomes 8 plus 11, which is 19, and the right hand side, which is 2 times p, so 11 minus 3, so this is 22 minus 3, which is also 19. Now both sides I get the same value 19, so left hand side is equal to right hand side for the value p equal to 11, so definitely it is going to be a solution. So yes, p equal to 11 is a solution. Now I want you to similarly check p equal to minus 5 by 3, and when you do that and put it in the equation, left hand side will not be equal to right hand side for this value of p. So we reject this solution and we say that p equal to minus 5 by 3 is not a solution. Why it is not a solution? Because it does not satisfy the given equation. So how many solutions does this question have? Yes, you are right. So this question has one solution and it is given by the value p equal to 11. So that completes your answer for question 1. Let's solve another kind of a question. Here, if you see, you are given an absolute value. You see these brackets, so you know this is going to be an absolute value equation. And in order to solve this, we are going to use the method of combining the like terms. You see the number 9 here, you see the number 13 here. Let's move it on the other side because we need the value of this absolute function. So 13 moves here, it becomes 9 minus 13, which is going to give you a negative number. It is minus 4, so you get 4 times 2y minus 7. Let me write here also as negative 4. Now what is common in both? You have 4 here also, you have 4 here also, so you can divide both sides by 4 just to simplify the equation. So this gives you the absolute value of 2y minus 7 is equal to negative. Now I want you to think, is this possible? Can the absolute value of a given expression be equal to negative? The answer is no. Why? Because in the beginning of the class, I told you that absolute value always gives you positive result. So absolute value of 2y minus 7 cannot be negative. So what do you think is the solution for this? Yes, you are right. This equation has no solution because this equation absolute value of 2y minus 7 equal to negative number is not possible. Therefore, you can give your answer, final answer for this question as the empty set or the null set. So I hope you have understood how we solve the absolute value equation for this case where there is no solution. We'll do one more question, and this time you will see that the absolute value equation, that is question 4 we are taking here, has two solutions. So let's solve this absolute value equation. You see these symbols, so we are going to keep this here, move the negative 6 on the other side. So the equation becomes minus 2 times absolute value of 7 minus 3y equal to minus 14 plus 6, which gives you a minus 8. Now there is a minus sign here also, so I can make the negative and negative positive. So this becomes positive and the common factor is 2, so I divide both sides by 2. So when I do, this equation reduces to absolute value of 7 minus 3y equal to 4. Now we have the equation ready, so we can go for the two cases. Case 1, when 7 minus 3y is going to be equal to right side positive, so 4. We have opened the bracket of absolute value. And case 2, where the right side is going to be negative, so 7 minus 3y is going to be minus 4. Let's now solve for the variable y. So I'm going to move this minus 3y on the other side, and this minus 4 and this 4 on this side, just to simplify. So what it becomes, 7 minus 4 is equal to 3y, and 7 plus 4 is equal to 3y. So what is your value of y here? 3 divided by 3 is value of y, which is nothing but 1. So one solution which I got from here is y equal to 1. Let's solve this also. So this gives you 7 plus 4, 11 divided by 3, that's the value of y, and I would like to just convert it into a mixed fraction here so that it can be written in this manner. So we have got two values of y. Now, in order to confirm that these both are the solution, we need to check our solution. So the last step would be to check, which you already know has to be done using substitution. So put y equal to 1 back in this equation. What you get is 7 minus 3 minus 6. Right side is already minus 14. If you get the left side also minus 14, khalas, we are done. So let's find it. 7 minus 3, this is going to be 4. 4 multiplied with minus 2, this is going to be um, minus 8 minus 6, which is going to be minus 14. So both sides are equal, so definitely y equal to 1 is a solution. Similarly, check y equal to 3, 2 by 3, put it back in the equation, and you would see that both sides come out to be equal for y equal to this. So here in this question, definitely we have two solutions. So the final answer is going to be the solution set 1, 3, 2 by 3. So now we have completed all three categories of question where you have one solution, two solution, and no solution. So in today's video, we considered all three kinds of question. In question 1, we had one solution. In question 3, we had no solution. And in question 4, we had two solutions. Similarly, I want you to try the remaining problems. Use the same method that I explained you in today's video and then check your final answer. Us to the end of today's session. I hope you found the video useful and you stay glued till this slide so that you have benefited from the whole video, and that completes part 1 of the multiple choice questions that will be coming for your exam. Next video would be part 2, so don't forget to like, share and subscribe. Also press the bell icon so that you don't miss the notification for my upcoming video. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.